Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we are going to learn the new chapter similarity. Okay, what does it mean by similarity? Okay, first of all, you need to know when given two non-right angle triangle, this is ABC, this is PQ and R. Okay, we can say that both triangles are similar if, okay, remember, if number one, the angle for both of them are equal. What does it mean by that? Let's say if, for example, I give you 25 degree, the angle over here also must be 25 degree. Okay, if I give the angle over here, let's say 80 degree, so the angle over here also must be 80 degree. Okay, so meaning that rule number one, you must remember, we can say two objects are similar if the angle are equal. Okay, the angle inside both triangle ABC and PQR are equal. Okay, number two, another thing, if we want to say the two objects are similar, the next thing that you need to check the side of the object. Okay, this is the triangle ABC, this is the triangle PQR. What does mean by check the side? Let's say if I say the length over here is 5 cm, the length over here is 7 cm, the length over here is 6 cm. Okay, if I want to say that the ratio of the side must be proportion between each other. What does it mean by the ratio of the side are in proportional? First, look the length of BC. If the large triangle over here, the big triangle PQR, if I want to enlarge ABC twice as the size of ABC, the length of BC is 7. What will happen to the length of QR if I want to make it twice bigger? So just multiply by 2. So over here will become 14 cm. How about the length of PR? It will become 12 cm. How about the length of PQ? It will become 10 cm. If you notice, from triangle ABC into triangle PQR, I make the scale enlargement by 2. Okay, so meaning that another rule to check if the triangle are similar or not, you must make sure the corresponding side, okay, corresponding side are in proportion. What does it mean by in proportion? Meaning that if this length I multiply by 2, so the rest of them also must be multiplied by 2. This one also multiply by 2. So that's what does it mean by corresponding side are in proportion. Okay, if the object satisfies both condition, okay, so we can say that they are similar between each other. Okay, but remember, when you say the object are similar, the size of the object can be different. Example like this, the triangle PQR is twice bigger than triangle ABC. Okay, another example, how to make it more clear. If you still confused, let's say if I give you example, Example number 1. Okay. Okay. Example 1. If there are two triangle, one small, one big. Let's say both of them are right angle triangle. Okay. Let's say this is ABC, this is PQ and PQ and R. Okay. The length from A to C is 8 cm. The length from C to B is, let's say, 6 cm. Okay, and then let's say here is X. Then let's say here is 12 cm. Okay, question number A. Find the value of X. Okay, find the value of X, which is the length of PR. Okay, how to solve this type of question? Okay, first of all, we must remember, since the triangle ABC and the triangle PQR are similar, okay, no need for you to apply the trigonometry or apply the Pythagoras theorem. No need. Okay, what you need to do is remember the rule that I showed you previously. It says that corresponding side must be in proportion. What does it mean by corresponding side must be in proportion? Okay, look over here. Okay, first of all, I need to find what is the scale factor of enlargement. Okay, we call scale factor. Okay, what is the scale factor of enlargement? Okay, first of all, look at the side of CB and the side of RQ. Okay, so one of the rule that you can remember, you must remember this thing. Very easy. Big divided by small. Big over small. Okay, so this is scale factor, which is represented by letter K. K is the scale factor. How to find the scale factor? I will apply this thing, something big over small. Okay, what does it mean by this big over small? Okay, look the triangle. Obviously, triangle PQR is bigger than triangle ABC. So, first, before I find the value of X, I need to know what is the scale factor from the length of RQ and the length of CB. Okay, I will use big over small, so 12 over 6, then equal to here PR AC. PR is X over AC is 8. Okay, rearrange, make X as a subject. So when you make X as a subject, you can do cross multiply. You can move this 8 to another side. So when you calculate, you will get X is equal to 16 cm. Okay. Okay, now I have question. I wrote over here letter K. What does it mean, this letter K? This letter K is represent scale factor. What is scale factor? Scale factor represent how many times the size of triangle ABC enlarged. Okay, so if you look over here, my calculation, when 12 divided by 6, we got equal to 2, correct? So 12 divided by 6, we get 2. This 2 is actually our scale factor. Okay. Okay. And then, what if? This is question number A. Question B. Question B, from the previous answer, find the length of PQ. Okay, I want to know what is the length of PQ. Just now we got already the value of x is equal to 16. In order to solve this question B, okay, so in order to find the length of PQ, since AB is not given, in order to find the PQ, what you can do is you just use the Pythagoras theorem. Okay, what's the formula of Pythagoras theorem? A square plus b square is equal to c square. So 12 square plus x square is equal to this s square we found already. 16 plus 16 square is equal to c square. What does it mean by this c? C is right over here. Okay, so you use your calculator. So c is equal to square root of 12 square plus 16 square, which is equal to, okay, wait, let me check, plus 16 square 20. Okay, so meaning that the length of PQ is 20. Okay, another example. What if the question gives, okay, another example. What if the question gives this thing? Okay, small triangle, big triangle. Let's say the angle here and the angle here 70 degree. Okay, and then the angle here and the angle here 50 degree. Okay, you must remember, when the angle are equal, so automatically both triangle are similar. Okay, let's give the name. This is PQR. Let's say this is L and N. Given for the small triangle, let's say the height is 4 cm. And then over here, the height is, let's say, x. Okay, and then let's say the side over here is 5 cm, the side over here is 8 cm. Okay, my question, find the value of x. Okay, how to find the value of the perpendicular height of triangle LMN? Okay, first of all, always remember, now we are still talking about the length. Okay, so first I will find what is the scale factor. Okay, scale factor. Always remember, in order to find the scale factor, big over small, 8 over 5. Okay, so 8 over 5 is equal to x over 4. Okay, how do I get this thing? I use the big over small formula. So 8 is from big triangle, 5 is from small triangle, x from big triangle, 4 is from small triangle. So based on this one, you rearrange, so you will get 32 over 5, which is 6.4 cm. So this is the height of triangle LMN. Okay, another thing you must remember, in similarity, okay, bear in your mind when you want to talk about scale factor. Okay, when you want to talk about the scale factor, you must remember there are three types of scale factor. Okay, scale factor number one, I show you already just now, to find the length, okay, which is represent by letter K. Okay, and then next one, they also can ask you find the scale factor of the area, and then volume. Okay, if length is K power 1, what is the scale factor for the area? K square. What is the scale factor of the volume? K cube. How to apply this? Okay, example, let's say I give you something like this, cylinder. Okay, small cylinder, big cylinder. Okay, let's say given the height, let's say the radius, the radius of the small is 5, the radius of the big is 10, the volume of the small given, let's say 120 cm cube. Okay, then the question, find the volume of big cylinder. How to find the volume of the big cylinder? Given the volume of the small is 120 cm cube. Okay, one thing you must remember, in order to find the volume, okay, the formula of the volume of any cylinder is, this is the formula. Let me write down the formula first. Volume is pi r square h. But the problem right now, we cannot use this formula. Why we cannot use this formula? We don't know what is the height of the cylinder. The height of the cylinder is not given. This one is not given, this one also is not given. So it is impossible to use this formula. Okay, we cannot find volume of the big cylinder just by using this formula directly. What you can do is, we will apply something that related to the scale factor. Okay, how to do it? Always remember, the scale factor, big divided by small. Always remember that. Okay, so obviously this is big, this is small. Okay, now this is also important. Length is K power 1, area is K power 2, volume is K power 3. Based on this question, we are dealing with the volume. Volume, we use K power 3. How to use this K power 3? Always remember, big over small. So I will use volume of the big divided by volume of small equal to K power 3 equal to K cube. Okay, so volume of the big we don't know. This is the one that we are looking for. So I'll just keep it as V. What is the volume of the small? 120. So equal to K. Now the problem here is K power 3. First, let's find out what is K. K is the radius over here, 10 divided by 5. Okay, don't forget the power 3. So 10 divided by 5, then power 3. Okay, rearrange, you make V as a subject. Okay, let me check. So 10 over 5 over 3. Okay, so multiply by 120, so you will get 960 cm cube. So this is the volume of the big triangle, a big cylinder, without using the formula of the volume of the cylinder. Just use the scale factor thing. Okay, even they also can ask you find the area. This is example of the volume. Okay, what if they are asking about the area? So I will keep the scale factor thing over there. Example number 5. If they give the shape like this, something like trapezium. Okay, this is the small trapezium, this is the big trapezium. Given for the small trapezium, let's say the base over here we put it as 8, and then over here let's say 24. This is not to scale. Okay, this is 8 cm, this is 24 cm, and then I give you the area of the big one is 250 cm square. Area of the small one is A, we don't know. Okay, now how to find the area of the small trapezium? Okay, I want to find the area of the small trapezium. Okay, this is the only information that I give. This is 24, this is 8, this is 250 cm square, and then this is A. Okay, for this question, always remember, no need for you to use the formula of the area. What you can do is use the scale factor. Since both of them are similar, so now we are dealing with the area, I am using the K square. So remember, big over small. So the area of big divided by the area of the small is equal to K power 2. Where do I get this one from? From here. What is the area of the big? 250. What is the area of the small? A. Then equal to, what is K? How to get K? 24 divided by 8. Okay, 24 divided by 8, but don't forget the whole thing, we must put square. Okay, so you rearrange, you calculate, you make A as a subject, so you will get 27.8 cm square. So this is the area of the small trapezium without using the formula of the trapezium. Use the scale factor.